Hello everyone, in this video I will show you how to solve a question that asks us to determine the convergence of a certain series using the comparison test. I'll do this using an example from a previous university exam from first year calculus, and the example we have here, as you can see, is the series that starts with n equals 1 goes to infinity of square root of n plus 1 divided by 2n squared minus 1. So to use the comparison test, let's see what it actually says. Basically what the comparison test says is we have two series terms, an and bn. An is the one that is given to us. So in this example, this is our an right here, these terms of this series. And we have another series terms bn, which we choose later. I will show you how. If we have those terms and they're both positive, what we can do is we can divide an by bn, we can let n go to infinity, and then we're going to get a number a. And then we just look at that number, and if it's positive, if it's larger than 0, then that allows us to say that the series of an and the series of bn have the same convergence behavior. So then if bn converges, an will also converge, and if bn diverges, then an will also diverge. So we choose a series bn, that's the first step. Second step, we do this calculation, and then we confirm that bn is the same as an. So let's just get to the example and see how we can do that. Here we have this example, and as I said, the first step is that we choose bn, obviously, because, well, we need a bn to compare the an to, otherwise it wouldn't be a comparison test. So how do we choose the bn? Well, an easy way to choose the bn is to look at this an that we are given and try to figure out how this behaves when n is a really large number. And when I say n is a really large number, I don't mean 100 or 1,000 or even a million or even a billion. Think trillions. Okay, if it's a really large number, well, then we look at the numerator. Well, this plus 1 is not really going to matter that much, because if you have a trillions and then you square root it, it's still going to be a huge number. Adding 1 to it is not really going to make any kind of significant difference. So we can just take this square root of n and we say this is the term that we're going to take from the numerator. Then we look at the denominator, and we can apply the same logic. When n is a really large number, then this minus 1 doesn't matter. Even this times 2 doesn't matter that much. But n squared, that's going to be really huge. So we take the n squared. So basically, we've just intuitively looked at how this expression that we have behaves when n is really large. And we can just subtract the powers here and simplify this, and we're going to get 1 over n to the power of 3 over 2. And so this is our bn. Great. So now we're done with step 1. So 3 more to go. And our second step would be that we have to be able to tell whether bn converges or diverges. So we determine the convergence of the series of bn. So how do we do that? Well, this should be really easy as long as we get our bn to be in this form, because there is a rule that we have that says, I remind you of this, if we have a series of the form 1 over n to the power of some number alpha, then this series will converge if alpha is larger than 1, and it will diverge if alpha is less than or equal to 1. So in this case, we can see that our alpha is 3 over 2. Our alpha in this case is 3 over 2, which is larger than 1. So that means that our series of bn converges. Right? So now we have this. When we're at this stage, bn is something that we chose that's very similar to an, we think. Right? So when we know that bn converges, we think that an will also converge because they're very similar, so we assume they behave similarly. But we don't know that yet, so we have to prove that mathematically. But at this stage, we can say that we expect convergence. But how do we prove that? Well, we can look back at the theorem here. Well, we're just going to do this computation here and make sure we find a number a which is larger than 0. Once we have that, if it's 2 or 4 or 100 or a half, whatever, we can say this is a positive number and Bn and An behave the same, and because Bn converges, An should also converge. So let's do that computation, and that is our step number 3. So we just compute the limit of n goes to infinity of An divided by Bn. And this is, well, our An is this. So we just put square root of n plus 1 divided by 2n squared minus 1. And we divide it by our Bn, which is 1. Divided by n to the power 3 over 2. In this case, you know from basic algebra that we just multiply the bottom with the top on the numerator over 2 times square root of n plus 1, and we divide it by the middle ones multiplied together. In this case, one of them is 1, so we just get this. We simplify this by multiplying this out, and we get n squared plus n to the power of 3 over 2, and we divide it by 2n squared minus 1. At this stage, it's really useful to just factor out the biggest factor that exists on both the numerator and denominator. So we look at which n factor is really big on both sides, and we just take it out. And how we take it out is we just write n squared, and we open parentheses because we want to take it out, n squared. And logically here, basically what we're doing is we're just multiplying this expression with n squared. So what do we got to do to equal it out? Well, we just divide everything in here by n squared. So n squared divided by n squared is just 1. And then n to the power of 3 over 2 divided by n squared is just 1 over square root of n. You can try it if you don't trust me. And here 2n squared divided by n squared is just 2, and minus 1 divided by n squared. Great. And now when we're at this stage, what we can do is, well, we can start looking at the limit. So we're looking at the limit as n goes to infinity. Firstly, this n squared and this n squared just disappear. And then when n becomes really large, so when it approaches infinity, when it's really large, what does this become? Well, when n is really, really large, like it's a trillion trillions, then the square root of n is a trillion. So 1 divided by a trillion or more is really close to 0, because the larger number you divide 1 by, the smaller the whole number becomes. So this is just going to tend towards 0, and it's going to become a 0. Here, the same logic. 1 divided by a super, super large number squared. Well, that's really going to be close to 0. So what we are left with is just 1 over 2. Which is really great, because what is our 1 over 2 as far as the comparison theorem goes? Well, it is exactly the a we're looking for, and it is a positive number because 1 over 2 is more than 0. So great. So now we can say that we confirm that Bn and An, the series of them, they behave the same with respect to convergence. And since we know that Bn converges, then An also converges. And so we've answered our question that An converges. If you're doing this in an exam, though, I would advise that you really write it down as step 4. Very clearly, something that looks like this, to say 1 over 2 is larger than 0, therefore a series of An and a series of Bn behave the same with respect to convergence, and since the series of Bn is convergent, our given series of An is convergent also by the comparison test. This can really earn you an extra mark in an exam. Great. Okay, so I hope this was a clear explanation for you to understand how to determine the convergence of a series using the comparison test. And to test that and make sure that you have learned this, you can try to do this series, which is quite similar but a little different. So if you try it, it will be a really good practice to do right away after you've learned these exact steps on how to do this. And it is the series of n, it goes from 1 to infinity of square root of n plus 1 divided by 2n minus 1. Here we use 2n squared, and here it's 2n. Try this and you'll find the answer to it in the description. And hopefully, using these steps, choosing Bn, finding the convergence of Bn, and taking the limit, finding a positive number, and concluding that they behave the same, you will determine the convergence successfully. Good luck.